You gonna post this one on YouTube?
Sorry?
Oh, I saw the one of our meetings was on YouTube.
Which one? Oh, yeah, if you want, I can put, otherwise I can skip. So, like, basically, if you need, like, to look it again, you can put it
Oh
there.
yeah.
If not, I can just skip. So, whatever you prefer, you tell me, right? If you don't want, I
No, it's
can.
fun. No, I just thought it was pretty funny because I Googled my name and then I
Oh,
saw the
oh.
video.
Is it there after Googling?
Yeah, you can
Oh,
search up my name and then you can see it.
is it?
Yeah, on Google. You just need to search up the Bindu, the Nanje, and
Uh,
then Maganama Etana. And then a meaning Etana.
oh, right. Okay. Anyway, let's proceed right now. Discussion. And basically, we are learning a programming language. When you are learning programming language, in initial stage also when we were discussing Scratch, here, like you can just note down this somewhere in your book. Especially when you are learning a programming language, we will first learn the concepts, programming concepts, or the software engineering concepts, such as what is SDLC, System Development Life Cycle, and how it works. So that is what we have learned initially, and we learn about some tools like flowcharts and pseudocodes. Why? Because this is how you design and represent that. And then we have to learn about the control structures or basic syntax, and after that, in the basic syntax, basically we will learn the words related to the language, composition, how we organize, and how we put them together, and how to convert a simple flow chart to a working program. Then after that, control structures. So there are three control structures that we have learned. We have to learn sequence, selection, and repetition. And also these operators are very important in language, so we will be learning that. And then we will be learning about the data types and structures. After that, we will be studying the data types and structures. After that, we will be studying about the algorithms, how we can use coding to do various tasks, like algorithms, how to get things done, how to solve problems, basically, methodologies, methods of solving problems. Okay. After that, after the algorithm part, we will be moving into file handling, types, structures. Under here, like we will be learning about list, tuple, dictionary, and sets. Okay. Tuple, dictionary, and sets. File handling, and then after file handling, we will learn about the database concepts. And finally, after the database concepts, we will be learning the database connection. And database applications. So this is how the topics are organized. So up to now, what we have covered is we have covered the SE concepts of engineering concepts and SDLC, and we learn how this life cycle works and what are the steps, basically, not in deep, but in basic. Then flowchart and pseudocodes, we have studied a little. Basic syntax, you already know that. And now we are in this part. Actually, we are around here, the operators we have discussed and the control structures. We need to complete that. And after that, I'll be moving to data types and the structures. Today, I think we need to continue the control structures part, where we will be studying the loops. Loops means repetitive statements. So you can take a screenshot of this basically because this is how it progresses, you just need to know the curriculum and what happens. Like then you can tell me which topics need to be done. This part done, this is done, and basic syntax, okay, operators done. But here partially, we have done it partially, not completed exactly. We have done this partially. We need to complete these parts. Okay, you can take a screenshot of this. Okay.
Yeah.
Right. Right. Now let's continue from that. And what we need to study today is we are going to look back into these control structures, where there are three control structures in the controls under the control structure lesson. There are three. The basic, the first control structure is called sequence. And in the sequence control structure, instructions are executed one after another. And in the selection, the second one is instruction flow is selected based on a condition. Please write down, and then based on a condition. And the third one is where repetition or iteration. This is where same set of instructions are repeated over and over again until, again based on a condition. Okay, these are the three control structures. Actually, here instructions. Then here what we are using is like normal the language operations, inputs, outputs, etc. But here in the second one we use like if else and switch case. We have already learned if else, but I will revise that, don't worry. Here we will be learning loops, right? This is what we are going to discuss today. Under today's lesson, we will be learning about the repetition control structure and how we can use loops. Okay?
Okay.
Right. So you note down this, or can you remember this, or are you going to note down?
I took another screenshot.
Okay. Hope you can refer that, right? Because like
Yeah.
the other one who like the other students, your friend, has done the same thing, but after some time he was telling my screenshots are missing for some reason, maybe a virus. Then all the notes are gone. So that's a problem, right? Basically, you have.
I copy everything onto a flash drive.
Okay.
Just in case.
Yeah, that's better. Yes. Okay. Let's continue, and in the repetition part, let's see what can be done. So here in the repetition, you can see the same set of instructions in this flow chart. Flow chart means this diagram shows the same set of instructions are repeating. So example, the instructions here, the print numbers from 1 to 10. You need to print numbers from 1 to 10. How this can be done? Let me logically explain this logical, this flow chart. You have to start, and here C is a variable. You know what variable is, right? Variable is a memory location where we used to store a certain change in value. It's like no, right? Okay, variable. It's like a mug. You can put any okay, in a mug you can put anything, right? In any amount. Any amount means that's a maximum capacity. Let's say this mug name is like, okay, name of this mug is X. And let's think that you're going to put some liquid there, maybe water. You can put 100 milliliters of water. 100 milliliter, right? You can put it there, but this is in a given time X. So you can say this is maybe 10 a.m. Since you utilize this, maybe when you look at this by okay, some time maybe somebody has utilized, or maybe you have utilized. The mug is same X. The mug has same X. But the thing is, let's say time is maybe now 10:30, and you will only 10:30 a.m. the morning. But when you see the mug, you can see only around like 25 milliliters there. That means the value has changed. But still the mug is mug. You can say, okay, bring my mug, bring my bottle or something. You can call. So it's still your bottle or still your mug, but you can see different amount of liquid there now.
Yeah.
Right? Okay. The variable is something similar to this. This like this metaphor. You can use this metaphor. You can use this scenario to understand variable. Okay, what is variable then? In a variable, it's a memory location. Variable is a memory location here. So what is variable? It's a memory location. Is a memory location to store a change in value. You can store a change in value there. Memory location to store a change in value. So you may note down this, right? Let's say you have a memory location in your random access memory or in your main memory. There is a memory location called C. The name of the memory location is C. Initially, the value stored there is number 2. Initially, the value stored there is number 2. This is what the statement says. C equal to means there is a variable, a memory location. You have to store 2 there. Can you understand?
Yeah.
Okay. Then in the next operation, you can follow the arrows. Here the arrow flows like this. The second arrow flows like this. It's downwards. And now you have a condition. In this condition, you are checking. In this condition, you are checking whether this C is less than or equal to 10. Is it true? In this condition, in the condition box, you are checking C less than C is, what is the value of C? It is 2. Is it less than or equal to 10?
It's less than.
Yes, it is less than. So you display C. Okay, in your monitor, in your output, okay, let me write this output. This may be your monitor for the stream.
I feel like we've done this before, since if C is less than 10, if it's yes, then C equals C plus 2, and then it keeps on going until it's correct, until it's false, and then it stops. We did something like this before.
Yeah. Yes, we did. But I just want to, yes, I just want to like refresh your knowledge. Yes, I just want to refresh your knowledge on this.
Okay, I was just making sure.
Because we need to do a few activities and understand whether the concepts are really okay with you, because I'm going to try some more activities. This is the same. And let's see whether like concepts are okay with you. And then because like we are meeting after a long time, maybe you have forgotten, like let's say, okay, is it okay, or shall I skip this?
Oh no, it's okay. I was just wondering if you forgot.
Oh,
That's the only reason I asked.
okay, that is right. Okay, now 2 is here. Now display C, the like you will be displaying 2 there, because it's C is 2 and C equals C plus 2. So means in your variable, in your memory, there will be alteration happen, and alteration happen here. Now C is C plus 2. So what will be the C now?
4.
It will be 4, yeah. It will be 4. Then now again you go here. You can see the arrows are moving up. Therefore, you need to move up. Arrows are moving up. Therefore, you are moving up. And again, you will meet here this check. You need to move down and check here C is less than or equal to 10. Here 4 is less than 10. Therefore, you do this again. What you need to display C. This time you are displaying number 4 in the string. Okay, after 2, number 4 will be displayed. And after that, again, you increase C by 2, and therefore this C will be altered. Now the value will be 6. Now the value will be 6. Right? Okay, now the value will be 6. And then you are again checking the 6 less than or equal to 10. Yes, it is. So you display 6 there. And what will happen? Then again, you increment that by 2. Therefore, the memory will erase the old value and put the new value. New value is 8. So after that, again, you display that new value 8 because 8 is less than 10. And you move and increase the number by 2. The old value will be replaced by 10 now because the new value. Yeah. Then 10 less than or equal to 10. 10 is not less than, but still it supports the equal operation. Therefore, 10 will also be displayed there. 10 will also be displayed there. And 10 plus 2 is 12 now. Now what will happen? This value will be erased and you can see 12 in the memory. Now you go and check. 12. 12, is it less than or equal to 10? Hello?
It's equal. Oh, 12, then it's
is it
larger.
less than or equal to 10? Is it 12 less than or equal to 10? Oh no.
No, it's bigger.
That's bigger. So you go there and stop the program. Okay. So that is what happened. Ultimately, this will display in the screen numbers from 2 to 10, which are even numbers. And even numbers will be displayed. This can be done in 2 ways. One is using a for loop. The second one is in a while loop. So you can display this in the screen. Actually, end value of C will be 12, but display value will be 10. You need to understand this as well. You're finishing at 12, but you display only up to 10, right? Because here, when it 12 only terminates, but 12 will never be displayed. When you terminate in, the value will be 12, right? Understood?
Mm-hmm.
When you terminate in this program, the C will be 12, right?
Yeah.
But will C be displayed here? C will be displayed here or not?
Yeah.
C will be displayed, or like 12 will be displayed or not?
It will.
It will display. That means 12 less than or equal to 10. No. You go this side and finish.
Yeah.
So you will not come this side. So 12 will not be displayed, right?
Yeah. The previous 12 will be displayed, but
yeah, up to 10 will be displayed, but 12
yeah, but 12 would not.
Will not. So that you need to understand carefully, that when you are terminating, the value is 12, but you will display only up to 10. Okay. So that is what the loop is. Okay. Now let's try these activities. Now you can share me the screen and try to do these things very quickly. So you need to display these patterns in your screen, just like icebreaker. Let's this is an activity to remind you the past things that we have learned. Try to display this pattern, and second, try to display this pattern. Third, try to display this pattern. And also try to display this. And also this. Okay, so you have 5 exercises. Let's see how many of these can be accomplished. You have to use the same, right? What is the syntax? I hope you can remember the syntax for doing this. Let me write the first example. Either you can do this way. Okay, you can say C equal 1 while C less than or equal to 10. print C end with space C equals C plus 2. This is one way of doing this, the first one. You can change that. Let me run this. Okay. And first one, sorry, C equal to, say C equal to. Yes, it's been displaying 2 to 10. Another way of doing that, you can say method 2 of doing the same is for C in range 2, 11 to starting from 2, stop when you reach 11, go 2 by 2, then print this C. This will also work. The second method is this. Okay, you can use one of these methods. This need to be go to the next line. Okay, 2 methods. I will send you this text, the first method and the second method. Now you can start sharing your screen. Please share your screen.
How do I run the program?
Sorry?
Where's the tab? Usually when you go to options, it should be there to run the program.
Yeah.
It's not there.
Can you share the screen? Oh, you have to take a new file. New file. Cut this or copy this text. And after that, go to file, new. And then you have to write there. In the file menu, new. Yes, new file. Then you can now run is there. You can write this. Okay, now you can run it.
What should I name this one?
You can save it somewhere. Put a name. Maybe you can put today's date. Anything. Okay. So can you try the other patterns, please? Can you try the other patterns, please?
Yeah.
Do I need to send the patterns to you? Okay, I will send it. I will send it in the chat. You can keep the screen on and share. And these are the other things which I expected to. Other patterns I have sent in the chat. Okay. So how these square numbers generated? How these square numbers are generated?
The square, mainly from the square root by 1 squared, like that, right?
Yeah, square numbers are basically square numbers, you know, the square numbers are generated like this, like first 1 asterisk. Okay, you can say the second square is 2 asterisk this way, and again it looks like square. Then the third one is 1, 2, 3 here, 1, 2, 3, and 1, 2, 3. That is the next square that is available. That is 9. The next is 1, 2, 3, 4 there, 1, 2, 3, 4 there, and 1, 2, 3, 4 there, and 1, 2, 3, 4 there. So altogether it is 16. So here 1, here 1 by, here 2 by 2, here 3 by 3, here 4 by 4. So this is how it's generated. That means you need these numbers, right? You need to go one by one. You need to go one by one. But one by one, C equals C plus 1. But you are not going to print that one. Instead of that, you can print C into C, right? Because you don't need 1, 2, 3, 4. Okay, if I write like this, please execute this code and see. Can you execute the code and see? Run it. Okay, click OK and run the code. Okay, now can you see the first is odd numbers, it's okay. The second is even numbers, that is also okay. The third is square numbers, but you're only getting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But you don't need this. What you expected is 1 into 1, 2 into 2, 3 into 3, 4 into 4, that one. So you go back to the code. Please go back to the code and mention there you need the multiplication of that. So how to get that? You can say C multiplied by C. When you're printing, you can print the fact like power. So in order to print the power, you can say C into C, C multiplied by C, right? Did you understand that?
Yeah.
You can say you need to print C into C. Okay.
Right.
Now run. Here you have to say C into C. Did you see that? Here. You are not just printing C, you are printing C multiplied by C.
Yeah.
Then what will happen? The first time 1 into 1. The second time?
You want me to run it?
Yeah, okay, run it and see. Now can you see the, like, see what has happened? No, the last one, can you see what has happened? Previously it was 1 to 10, no? Previously it was 1 to 10 here.
Yeah.
But now, since you are printing C into C, you are getting the square numbers, right?
Yeah.
Okay. Here to here, what is the update that you have done? You have printed C first time. The second time you have printed C multiplied by C. The printed output is different. Understood?
Yeah.
Okay. Can you try the other patterns? There are two more, sorry. There are 2 more. I will give you like a small time. Just think. At least, okay, no need to print. At least tell me how this pattern is generated. Right? Even if you cannot write the code, that doesn't matter. But tell me how the pattern is generated. That is still important. Because you need to first understand the question. After that, you can do it. Okay, tell me how these last 2 patterns are generated. Just analyze the patterns and tell me.
The first one, the 1, 3, 6, 10, 15, and 21, that's cubed. Am I correct?
Cube.
Yeah.
Cube means 1 into 1 into 1. Okay. 2 is 2 into 2 into 2 is 2 multiplied by 2 is 4 plus 2. Right? 4 into 2 is 8. Then 1, 8, right?
Oh, then the triangle.
Yes, it's triangle. It's triangle. Correct. It's a
Yeah.
triangle. Yeah. Correct.
I always get confused with cubed and triangle.
Okay. It's triangle. So basically it's triangle numbers.
Yeah.
How the triangle numbers are generated? It is also like that square numbers, right? You know, it looks like triangles. 1. The first triangle is 1. The second triangle is like this 1 plus 2. It looks like triangle. The third triangle is 1 plus 2 plus 1 plus 2 plus 3. And the third triangle is 1 plus 2 plus 3 plus 1 plus 2, 3, and 4, that is 10. Here 1, here 3, here 6, here 10. So this is how triangle numbers are generated. Always add 1 extra value to the existing total. Okay, now you have to try. Try to print that. Just try to print that. And if you can erase that point, let's try to do that now. And so, okay, it's like this. Let me share my screen, and you can try that in your one. Okay. Here, in this one, I can tell this third one, the triangular numbers. Print triangular numbers. Maybe the first triangular number I can say Tn equals 0. Then I can start from 1 and move 1 by 1. Or I can use while loop, anything, right? Starting from 1 and move 1 by 1. I'm printing the first triangular number Tn. But before printing that, I will get the Tn and add Tn C. First time C is 1. Okay, these are two variables now. Two variables means two memory locations has two values. Okay, first memory location is this, second memory location is this. Let me name the first memory location. This is Tn. The second memory location, which is C. Now two variables are there. The Tn is 0 initially, and C is starting from 1. C is 1. So what you tell? Tn equal Tn plus C. Tn is 0. 0 plus 0 plus C is 0 plus C is 1. So it is 1 now. You try to understand, right? It's 1 now. Now you are printing that one in the screen. Okay, you need to monitor as well. In your screen, you are printing the Tn. In your monitor, you are printing the Tn, which is 1. In the second round, C will be automatically incremented to 2 because C is going 1 by 1 here. C is going 1 by 1. So C will be 2. Now, what will be the Tn? What will be the Tn? Yes. If C is 2, what is Tn? Tn equal Tn plus C. Tn is existing Tn is 1. 1 plus 2 is
3.
3. Okay, this will be 3 now. And that 3 will be printed. And now C will be 3. Okay, what will be the Tn then? If C is 3, what will be the Tn?
So the Tn is 3 and C is 3, and then it's plus C, so it would be 6.
Yes, it's 6. So 6 will be printed. And now C will be 4. What will be the Cn? Tn?
10.
Yeah, 10. 10 will be printed. And this will be 5. Can you understand what's happening there now? Two variables are used. And this will be 15 now. And that 15 will be printed. So it's easy, right? Only thing is you need like only one variable is not enough. You need one variable which is going 1, 2, 3, 4, 5, 6, 7, 8 way. That is C. The second variable is Tn, which is collecting these values and assigning it to that. Okay, when you write that and run this code, you will see that pattern in your screen easily. That is what the triangular numbers are. You can see the first and triangulars are also there. And you can use while loop also. Okay, let me do the same using while loop too. Hope you understood this concept, right? I'm erasing the screen.
I have a question.
Yeah, you can answer.
Oh, actually, never mind. Hold on.
Okay.
I think I understood what I did wrong.
Okay. While loop, you can do the same thing. Let's use the while. Maybe you are confused with the for loop. Then you can use while loop. you can still say that tell the same TNC is this, and then it's not needed, and you can say while C is 1, while C is less than or equal to 10, you do the same. And after each round, you can say C equals C plus 1. So in case if you confuse with the for loop, you can try this while loop, still it will do the same. So C is incremented 1 by 1 here. C is incremented 1 by 1. Tn is incremented by adding 2 to adding C to that. This is the corresponding while loop. Okay, you can try this both. You can try both of this. You can try and let me know. Then let's do the last pattern after that. After you try, I'll do the last pattern. If you're done, please give me.
I need some help.
Yeah, sure. You can share.
It keeps on saying that this is wrong.
Oh, the reason is method 2. Method 2, you need to erase. That is not a part of this. Method 2. No, the next line. Next immediate line is not a part of this code. It's just a comment. The 4, that part is not right. Now I think it won't happen. That's not a part of the code.
Yeah.
Okay. It's printing now. Go back to the code. Please go back to the code. You have to print TN, right? Not C. You have to print the last line. Yeah, TN. Because C is just 1, 2, 3, 4. The TN is where you get the triangular value. Okay, great.
Yeah. All right.
Okay. That method 2 is just a comment. It's nothing.
Yeah.
So, that doesn't matter, right? You can use capital TN as well. That is not a problem, right? You can use capital TN, still it will work, right?
Yeah, but every single time that I was like getting it wrong, it kept on highlighting the lowercase t red.
No, the reason is the previous line. The error in the previous line has highlighted the bottom line. That is the nature. Normally, when there is error here, let's say there's error here, this line will be highlighted. That is normally here. Let me run this and show you. You can see invalid syntax. This line has the error. Previous line has the error, but sometimes the next line will be highlighted. That can happen. Right? That can happen. So therefore, like don't confuse with that. Okay, the last one is the Fibonacci. This Fibonacci is a very, very special thing. Fibonacci is a number series. Right? Fibonacci is just a number series. That is what you see in the last pattern. You can see these Fibonaccis are generated by adding previous 2 numbers. Always adding previous 2 numbers. You can see 0 plus 1 is 1. 1 plus 1 is 2. 1 plus 2 is 3. That plus that 1 plus 4 is, yeah, that's 5. Likewise, adding previous 2 numbers. Adding, right? It's always by adding previous 2 numbers. Fibonacci, right? It's by adding previous 2 numbers. You can see. By adding previous 2 numbers, it is generated here. 1 plus 1 is 2, 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 5 is 13, 13 plus 8 is 21. Okay, this is how the number pattern generated. Understood?
Yeah.
Okay, but this is like naturally, this Fibonacci has a big relationship with the real world. You can see this generated arts, or maybe a shell of a snail, composition of a flower, maybe even our like proportions in our face, here, proportions in our face and body, like here Fibonacci in real world. In real world, because this pattern can be seen many places. Can be seen in many places. Yeah. See. And this has, okay, this has a Fibonacci base generated. This shell has a Fibonacci base. This you can see pineapple and this horn and all. Everything like it has the Fibonacci, like Fibonacci look. Here, this Fibonacci. It's here you can see even this. This follows the Fibonacci, and many places, even this mouse, rat, the structure of Fibonacci. So here in your ear, it has Fibonacci. Egg has Fibonacci. In a face, it has Fibonacci. In a fingerprint, it can be seen. In composition of this flower, you can see that. Right? So it's many places. Even in the you can see this. Right? That's the reason, right? This number sequence is really important because it shows it has a lot of relationships with the real world phenomena, the pictures, things, visuals that we see. You can see it follows this Fibonacci rules. Therefore, it's very important. And that's what this last pattern is. It's about Fibonacci. How can we generate that? So we have to first tell them, first two you need to generate manually. That is God generated, right? It's not God. But anyway, first two you have to tell manually. Fibonacci 1 is 1. Fibonacci 2 is also 1. But the next Fibonacci next is basically Fibonacci 1 plus Fibonacci 2. That is for sure. Fibonacci next is 1 plus 2. And after getting the Fibonacci, you can print that Fibonacci. You can print the particular Fibonacci. Or before that, you have to print the Fibonacci 1 and 2 also. Okay, let's print the Fibonacci 1 and 2 also. Print F1 and F2. And after printing that, the next Fibonacci is addition of those. So this will simply print the Fibonacci, but this will not repeat. No. If you want to repeat the process, okay, this is Fibonacci. So let me check the spelling. F-I-B-O-N-I-C. Okay, this is what the Fibonacci is. And it's basically printing the first three fibs. First three fibs. That is, you can see, first one of the triangulars. And then, here, this is what the fibs. These are the fibs which are printed. Okay, here what we have done, let's see, T and this T has a problem. Okay, sorry, it's capital T to be that. Okay, run it back again. And see that it's generating this 1, 1, 2, 1, 1, 2. But okay, let's end with the space. End in its space is needed. Otherwise, if you go to the next line, end in its space, end in its space. Now it will remain in the same line. You can see the first tree only, but you need to repeat. When you're repeating, you can say, but now you know the fib 1, fib 2, you can generate the next fib. You can repeat this process. If you know the fib 1, fib 2, you can generate the next fib. And you can say the next fib 1 will be fib 2. And next fib 2 will be fib next. Because you need to update. After generating, next fib 1 is fib 2. Next fib 2 is fib next. Now, if you repeat the process, let's say for k in range, you need 10 times. You can say for k in range 10. You do the same. Now, 10 times this will be repeated and the next set of Fibonacci's will be generated. Okay, see, 1, 1, 1, 1 plus 1, then that plus 2, that plus 2 is 3, that plus 3 is like 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 5 is 13, 13 plus 8 is 21, 21 plus 34, right? Plus it keep on generating fibers. Understood?
Yeah.
So we can wind up the today's class with that. We have practiced the loops again. And I think that has given you a sound understanding of the topic. The next day, we can continue to learn about the data structures, list, tuples, and dictionaries. Okay, take a screenshot and see you in next day. And try this, right? Okay, bye.
Bye.